Hello everyone, this is Team Whitehawks presenting our academic project called ML Task Scheduler. So in this video, we will demonstrate the whole project to you. So let's begin it with the main page. So ML Task Scheduler is an intelligent task allocation for fog. So firstly, we had mentioned the tech stack that we had used in the project. So this project is based on the research that was done by Wang and Lee in 2019. So this project is inspired from a research paper. In this project, we have used 16 database models, 53 plus API endpoints, 6 algorithms, which are bio-inspired and classic one, and 103 backend tests, and all are passing. And we also compare the old algorithm with the new algorithm that's implemented in the research paper and the 31% energy saved that we observed. So, in this platform, we have bio-inspired scheduling. As I mentioned earlier, there are 6 algorithms, which are the IPSO, IACO, hybrid heuristic algorithm, and the old one, which are FCFS, round robin, minimum and minimum, delivering up to 31% energy saved reduction over baseline that we will also see in the app also. So we have ML prediction engine, three-layer fog architecture, live telemetry, production security, real-time updates. So the ML Task Scheduler platform is the fog scheduling, ML prediction, telemetry, and production infrastructure all in one. So in this whole project, we have 11 full stack pages, which are fog computing, in which we done the algorithm comparison. Then the devices, where we have the IoT management devices, and the analytics, where all the charts and dashboard and the simulations are in there. And the task, like thread operation and filters, the experiment, which is purely based on our research paper, the dashboard, where the individuals can check out their work in which they are working on, the Kanban, which is used for managing the tasks, the ongoing, the done, the failure, and all. Chats and mail for team collaboration, and the resources for load monitoring on the notes and the profile. Each individual have their own profile; they can manage it in this page and the authentication. So the team behind the whole project is Sri Srivastav, the leader, Ekshad Dwedi, and Aditi Singh. So these are the production that we have used. Now let's go into the web. So yeah, this is our login page where you have two options: sign in. Like if you are an existing user, you can sign in with your details, and if you're not, you can use the sign up also. So we are here gonna sign in with the Google credentials. So let's go. Yeah, this is the dashboard of ML Task Scheduler. Before going through its feature, let's go through the structure of ML Task Scheduler. So we have the main section. We have the three pages, dashboard, calendar, and task. Then we have the app section where we have the email page, chat page, and Kanban. And then we have the system section, which have the major and the most important portion of our web application resources, devices for computing and chaos console. Then we have the intelligence section where we have all the ML models and experiment and analytics behind that. And we have access control where the team, if we have the team collaboration, users can add another user, admin can assign them roles, and the permissions are granted from here. And then we have the page section where user can see their profile and an FAQ page. So let's go through the dashboard page. So we have here the search option. And currently, like we are live engine, so it is showing the live. We can switch the modes. Currently, it's the dark mode. We can switch to the day mode also. Here you can see we have the notification regarding the experiments, the no critical, and if any task going to be scheduled today or anything like that, we also have that notification here. And the simply you can see your email and this, if you click on the setting, you simply locate it to the profile section that we just see. You can see here. So moving back to the dashboard. In the dashboard, we have the executed pulse option. Like if we click over here, you can see the changes that we will see in the processing metrics. It will take some time. Till then, yes, you can see here like this. Yeah, all the changes that we execute the pulse when we execute the pulse are going to show here. Yes, and this is the neural optimizer which show the scheduling task using deep performance. Then the 30% global resources utilization that the shown in cluster workload. Here you can see the 6 active tasks, 2 system nodes, the current power efficiency 30 kilowatt and 1.45 ms neural latency. The layer allocation for the active layers, which showing that fog network have 2% over there. Active pulse, like if there are any active pulse, you can see it here. We can also inject pulse to enhance or to make most out of the task, so that we can show here. And recent pulse transaction, there is none, so it is showing nothing. Yes, we can also do this, like we can simply enter the task, neural mix, this, and inject the pulse. So as I injected the pulse, that is going to show me in the recent pulse transactions here. We can also delete it from here. Now moving to the next section, that is the calendar one. So the calendar one is like you can simply assign the task according to your day or time. Like if you wanted to assign a task, let's take an example. Like if you wanted to assign a task, uh, assignment, let's say task 1, task 12, I want to assign on uh, 14th of August. Duration will be 15 minutes. Standard will be small. Okay, workload will be small, and it will be an input-output bound. So let's take an example of it. Let's save this. As I saved, it is showing me here that this is the task which is assigned me on the 14th August. I can see this on a monthly basis, weekly basis, daily basis, and also if I want to see the list of all tasks that is assigned, so we can see here. There is also the status filter we can check here, and the workload type. So yeah, this is all about the calendar page. Now moving to the next page, which is the task. So this page is used for adding new tasks, searching for the existing tasks, checking if they are pending or anything. So we can easily search for the task, like the task we created now, which is a task 1, 2. Yes. So you can see it is showing the task. I can also search it with the status of it, with the type of it, and I can also add the new task here, like I did earlier. So there's one more feature that we added in the add new task feature in the task page, which is the description. I can describe about my task, that how heavy it is, what's the work it is going to do, and all the things. So we can simply create the task, and we can also assign with it our calendar. So yes, and we can also export our all the tasks that we created or that we had in the list. You can see here. Okay. Now moving to the next section of our, which is has apps. So in the apps, the first page is the email page. So section uh, where team collaborations and the teammates can contact to each other, take the updates and solve each other's queries, share any attachments. So it is simply we can compose the mail as we did in the Gmail accounts. So let's take an example for that. Let's compose with a demo account that we mentioned here. Let's take this Dr. Alex. So I want a quick update from him. Quick update. I want to check about his updates over the last project. So you can see the message has sent for the updates, and yeah, here it is. Quick updates. I want to check about the updates over the last message. It's showing in the inbox section. Now the next page in this app section is the chat, which also have a feature like you can contact with your teammates, take updates, and help each other through the project. So like this is the demo contact that we have taken. Also, we are providing the Nova AI assistance. Like if anybody have any query, they can easily ask. It will gonna help you over the whole project. Let's take an example. What is the current cluster load status? It's going to show me here. Okay. So the next is the Kanban section. So it is like the section in which we can see what's the status of our projects, like our tasks. So basically, like we have two tasks, which is the to do, which we assign for the dates. The system one is assigned for the 13th August, and this is we just assigned for 14th August. So when these tasks will going to be performed, this will going to show me in the in progress section. Then the task is done. Then it's going to show me in the done section. And if any error or anything happens which make them fail, so this section show me the failed task. I can also add new tasks from this section. You have that task name, CPU intensive, priority level, duration, and column status. Simply that we did in the calendar section or in the task section also. And we can simply create the task. Yes. We can search the task. We can apply filter to search the task. So this is all about the section. Now moving to the next section, system section with the resources page. This is the resource this page. So this is the resource inventory where we can see the total nodes, which is 2 right now. Available is 2, busy 0, and average load is showing 30%. We can easily refresh the data, add new nodes. For example, let's take a node 2 with a capacity of 10, and we can easily add resources. So here it is node 2. The resources load 0%. There is no resource that we load to it. Yeah. So the first node that we had, M node, which have 2 queued active tasks. New node also have 2 queued active tasks with a capacity of 5 minutes. The node we just created don't have any task that is assigned it have. So cluster management, let's take a node that we just created, node 2. You see it is available currently. And yes, and if I want to check the cluster health, it is 98.4% and total throughput is 4 seconds. So yes, this is all about the resources page. Now let's move on to the next page, which is the device one. So this device page is for the IoT devices that we are going to connect. So currently we don't have any IoT device connected, so it's not showing any device. We can simply add any frozen device, name the device, hardware architect, operational status, offline, static IP, control protocol, geographically network location, and easily initialize the node into it. So yes, this is the page for the IoT devices, and we can sync the hardware also here. And all the IoT devices we're going to list here, and we can easily search them with the architecture they have, the all states, and if it is online, it will going to show me here maintenance error, all the things going to be mentioned here about the all IoT devices. And then the next section we have is the for computing. So for computing that I also mentioned earlier in the main page. So this is the main thing behind our project, which contain the hybrid heuristic algorithm, which replace the old algorithm that is used for the for computing, that is the first come first serve FCFS and round robin algorithms. So what hybrid heuristic algorithm did they combine? It combined the IPSO and ICO algorithm. So here we have a simple simulation for it. Like task bit size is 50 and we selected heuristic algorithm, hybrid heuristic algorithm. I run the simulation for it to show me the total delay 162.36, energy usage, reliability, and compute time. Now, if I want to compare all six algorithms, so here's the comparison. Heuristic algorithm delay is this. Energy is 15 joules, reliability is 16, and runtime is 540. IPISO. And you can see the difference between the first come first serve and hybrid algorithm. See the difference. You can easily see the round robin also they delay and minimum delay. Is all comparison. I can see the comparison with the charts too. It will take us some time. So it's going to load here. Yeah, here is the chart section, which is showing me the comparison between all the algorithms. You can see here at each and every point. We will also going to check it when we apply the chaos console and the ML models. Yeah, here is the reliability versus maximum tolerance time. You can see as less as it is possible, as good as it is going to be. So here you can see hybrid heuristic algorithm has the less on the figure and the first I round robin have the highest. So on the basis of that, hybrid heuristic algorithm is best for the computing. Now moving to the next section, that is the chaos console. So chaos console is basically a feature that we added to the our web. We integrated a custom chaos injector in chaos service.ts to validate system resilience. User can inject artificial network latency 5000 ms plus error spikes and node failure directly from dashboard to evaluate system behavior, auto retraining triggers and circuit breaker. Let's take an example. Let's take the latency injection. I want to inject the fault. I first have to abort this and now I can simply inject the fault injection. Okay, wait. Uh, let's take it on ML services. Yeah, yes. Now I can show you the changes that occurred over here. You can see the figures are changed now. Like lastly, it's showing 2500. Now it is showing 2086. So this is the work of Chaos Console, where we can simply minimize the duration, minimize the getting fault or error situations. Now moving to the next section, the intelligence section. So the next section, we have the intelligence section where we have the analytics page, where in the analytics page, we have the real-time telemetry, continuous reinforcement, learning performance, and ML efficiency metrics. So we can see the last 40 days, the last 30 days, and the last 90 days work. Here you can see the ML efficiency is currently plus 54%. Prediction reliability is 82%, which is super optimal. And the total schedule that is done is 96. Average latency is 1.45 seconds. So here we have ML performance forecast, ML model performance metrics, and the simulation for the task status with the pending schedule completed and failed, the task type distribution, resources load distribution, and the comparison between the machine learning versus the heuristic benchmark. And we can see the difference with throughput, resources efficiency, execution latency, and error rate. So this is the basic analytic page. And the next page is the experiment page where we can, which is purely based over the research paper. We can simply experiment the ML models here. See if I want to improve ACO, I simply continue with it. I can enhance it with the maximum iteration, population size, and all, and apply the changes, cloud central edge gateways and all, and continue and launch the experiment. So the reliability increase with the tolerance. Heuristic highest reliability tolerance is also increased. I can see it with the energy consumption. Let's take sample iteration 3 and execute the benchmark. So the simulation progress is showing the last run status completed. And here's the simulation for this. I can also download the result that is generated. Like, yes. And I can use the custom hardware from the world data sets, which are available. Like we don't have currently any data sets for that. So we are using this and we can train the model over that. Like here we can see it is trained over 500 tasks and each one of them is currently taskable. So yes, we can train our model over it. Now moving to the next section, which is the ML model, accumulated data with it, system health, which is currently showing the online. We can see the performance evolution over the last 10 models or last 30 days. We can easily select it on our basis. Then we have here is the version history, the training data, the current status, its accuracy, and each model's accuracy you can easily see here. Then we have a global feature importance, where we can see the task size, hardware capacity, resources load, priority, and network latency. So the training pipeline is showing me this, that custom trace training job, which is have samples 500, which we used, and currently we are also using that. So that is all about ML model. We can also customize it with the traces and hardware. If we have hardware, we can simply custom it with the hardware we added. And if we don't have one, so we can use the one we provided. So yes, you can see the model retrained here. We can trigger the retrain. So here will be, you see the model is retrained. Yes. Now moving to the next section, which is the access control. This is for the team collaboration. Like if you have any team and you want to add new member to your team, you can easily use the add user option to add more members over your team. And you can check their status if they are active currently or not. You can remove them from here. And also you can have the list of the members. Yes. And the next section is the role, where you can assign the roles to each of the user. If you are admin, you can add more user to your project and easily assign their task, their role. If anyone is going to managing the task, that you can assign them a role of manager, and if anyone is going to going enhance the task with the developing skills, you can easily assign them as a developer. So currently there is 2 users, and we can simply add new roles here. We can search the members, and then the permission section, where you can see which user have it, the permission of to access any specific section in the web application. We can add permissions and also remove from the list. Then in the next space section, we have a user profile option, where a user can add profile photo, reset their profile, add the first name, last name, email, and the basic details, and they can save the changes. And if they want to deactivate their account, they simply can deactivate in the delete account section. And the last page is the frequently asked question. If anybody have any query regarding the websites or anything or any error is occurring in their web application, they can simply raise a query here and ask their question for you. So this is all about the ML task scheduler. Thank you.